In this video segment, we're going to be going through the 4-jaw self-centering chuck. And what we're going to do is remove the standard jaws and install the master jaws or the pie master jaws. It's a fairly tedious process, but you have to follow very specific instructions in order for everything to fall into place. When you look at the jaws themselves, the bottom of the jaws, each one is different. The tooth pattern is completely different on each one, specifying that each one has to go in a specific order in the truck to line up with the scroll, so they're all coming in and out together. And then we'll go into mounting the pie jaws, which are just exactly what they are, pie jaws. They're very precisely machined to fit specifically these jaws. And then from there, we're going to machine the pie jaws and actually cut a blank clock wheel, a brass clock wheel. This is the blank I just knocked out of some brass. We're going to shim it down and true it up and drill a hole in it, and we'll go from there. Okay, to remove the jaws, if you haven't done it before, all you need are your 2 Tommy bars. Put one in the outer ring, one in the inner ring, and just start rotating it until the jaws come all the way out. And there they are. Okay, this is where it gets a little kind of tricky, and you have to really pay attention to what's going on here. Because if you look, each jaw, the tooth pattern on each jaw is very specifically different, and they have to be laid out in a very specific manner in order for them to go into the scroll correctly. Now, in the instructions, it lists it and labels everything extremely clearly and very concisely, and I urge you to follow the instructions word for word verbatim, and you should not have any trouble doing this. It is kind of a learned process. You kind of got to fidget with it a little bit to get everything to drop in, because you're doing 4 jaws simultaneously, and 3 or 4 extra hands wouldn't be a bad idea sometimes. But if you can see in the diagram here, we have the number 1 jaw, we have the number 2 jaw, we have the number 3 jaw, and we have the number 4 jaw. And those are laid out specifically because you start the process of inserting the jaws 1, 2, 3, 4 in A, B, C, and D. And when you're doing this, you can kind of see the scroll rolls in and out. And where you want to start is with the scroll at its, let me see here, where is it? Okay, that is the starting point. You can see in this that this distance here is the largest it's going to be in the rotation. As I rotate it, you can see that distance gets smaller. You want it to be the largest it is, and you'll see the next scroll rotation start to come into view. What you do there then is you insert the first one. Use your handy dandy T-handle. Come on. There we go. Then you go to 2. You go to 3 and C. And I got it off. You can see these are going in much farther than this one is. So that's kind of good. You can see what happens when that does that. There we go. And then D. And as you turn the scroll, you kind of want to help the jaws in. And once they're about a third the way in, then they will drop all the way in, and they're as they should be. Okay, now that the jaws are mounted in the chuck, we're going to take a look at the actual pie jaws themselves. We have them in steel, and we also offer them in aluminum. And these are very precisely machined jaws that are designed to interlock with the master jaws themselves and then secured in place with a 540 screw. And essentially all you need is your 3/32 Allen wrench. I'm going to describe exactly how this fits in and why it works the way it does, and we'll get a little closer in for that so you can actually see the jaw integrating into the master jaw. Okay, I'm going to show you how the jaws actually interlock with each other. This is the master jaw. I brought an extra one for demonstration purposes. You can see that the spur is radius cut, meaning it was cut on a radius when the jaw was actually fabricated. So that will fit into the circle cut on the actual jaw. And then we have a radial straight cut. And the jaw itself interlocks very snugly into each other. Very tight, very snug. And then you simply drop your little screw in. And that's it. It isn't going anywhere. Very tight, very snug, very positive. And now we're just going to simply mount the jaws. Each jaw does have a corresponding laser engraving letter to correspond with the correct spot on the chuck. This is A. Obviously it will go into A. You just lock it into the ridges and put your little screw in there. And just snug these down just so they make contact for now. And the last one. And there they're mounted. Now I have to be very specific here, in that these are machined the same way that the original Swiss pie jaw chucks were done. There is an interference fit between the chuck face and the jaws, meaning if you tighten this down, you will lock your chuck. And that just gives you a very precise movement that when you're adjusting it, you essentially just do a slight snug and it will still move, but it's very permanent and fixed down to the face of the chuck. Now what you want to do here is put your 1/4 inch dowel pin in and actually bring it down. And what you're doing here is you're loading the teeth in the direction you want them to go. Tighten them down to seat them, and then crack it loose and just snug. Crack it loose and just snug. And that sets the movement of the jaws. And then from here, back it off. I don't have it too tight. Oh, there we go, going the wrong way. From here, we'll push the dowel pin in just below the surface and then lock it, tighten it back down. And then from here, we'll mount it to the lathe, and we'll actually start the machining process with the pin in there to hold concentricity on the jaws. And now, obviously, we're ready to mount the chuck. Just like in the last video, spin it on, lock it down with your Tommy bars. Make sure your jaws are nice and tight. And then there's several different ways you can do this. I prefer just the standard 80-degree carbide boring bar because I'm going to be going so shallow in here because my gear blank is not very thick. So I'm going to be only going in about half the depth or half the thickness of this brass disc. So the angle on this particular boring bar will work quite nicely as I start at the open hole and just work my way out until I get my diameter. This is actually 1 3/4 inch diameter, so I'll be coming out quite a ways on the pie jaws, and I'm doing that to demonstrate that you can hold rather large clock wheels in the pie jaws. And you just simply mount the boring bar as standard in the 7600 tool holder. And you can have this pretty far in, so there's no chance of chatter or anything, because again, you're going so shallow into the material.
What are pie jaws for?
Making clock wheels. Doing very thin, large diameter.
Do we want to assume that people know what pie jaws are for, or?
We can go into that as I'm cutting it. And we zero it. Just touch off. Zero your hand wheel. And back it off a little bit. Go get the point onto center and figure out how far we have to go. Okay, this is 100 thousandths thick. I want to take it down quite a bit. So I'm going to cut the jaws to 25 thousandths depth only. And here we go. I'm just getting a rough diameter here to start with to get to my depth, and then I'll bring it out the rest of the way to the 1 3/4 inch. During the commercial break, I actually pulled the tool back and measured everything, and I nailed it perfectly. I'm exactly 25 thousandths depth, and the bore so far is 1.444 inches. I need to go out to 1.755. I have everything set to do that. I'm just going to start at the existing cut radius and bring it out, and then just do a final very thin skim pass at the very end to blend the base of it. Okay, I'm within 10. I'm going to pull it away and do another measure. I'm not going to move my tool post. And that is the bore. And then the final step is actually mounting your piece in the chuck. I did change over from the boring head or the boring bar to the turning tool. Do not forget to remove the dowel pin, which frees up the chuck. Open it up a little bit. Mount your gear blank. Now the jaws, the chuck is only holding on to 25 thousandths of that gear blank. But the fact that it is covering almost the entire circumference of the blank, it is holding on extraordinarily well. And that will afford us to be able to machine quite aggressively and thin this clock wheel blank up. Incidentally, that's kind of where the pie jaws were designed for. It was in the clock and watchmaking industry, but that's not to say that's their only use. They're very good in doing very delicate, thin parts that are very difficult to hold any other way. It gives it a nice backing surface, meaning you can put pressure on it and it isn't going to bow away from the cutter. And being it's almost full circumference of the part, it holds very well. And that being said, we can start turning. I'm taking 20 thousandths of an inch depth cut, and I can cut to almost the face of the jaws. And we'll call that enough, just for demonstration purposes. Now from here you could very easily just take the whole chuck off and move it to your rotary table and drill your mounting hub locating holes. You could even do some fancy scroll work with a rotary table to do spokes to finish up your clock wheel. And went from 100 thousandths thickness to 28 thousandths. And that's how you use the pie jaws.